Hello, welcome to this video. In this video, let us take one more problem on multi-stage air compressor. So, let us read the problem. A two-stage air compressor. So, number of stages has been given. A two-stage air compressor compresses air from 15 degrees Celsius and 100 kilopascal. So, we already know the first point is the initial point. So, let us start from there. So, P1 is 100 kilopascal, 100 into 10 power 3 Newton per meter square, and temperature is T1 15 plus 273, that is 288 Kelvin to 6000 kilopascal. So, the delivery pressure is given 6000 kilopascal. Okay. The air is cooled in the intercooler to 30 degrees Celsius. So, we have first stage compression 1 to 2, then intercooling is done. Let us call this as 2 dash, then again it is compressed further. Okay. Now, the intermediate pressure, so this must be delivery pressure then. So, the given value 6000 kilopascal is P3, that is delivery pressure. The air is cooled in the intercooler, so T2 dash is given then. So, according to our diagram, the intercooled temperature T2 dash is equal to 30 plus 273, that is 303 Kelvin. So, that is our T2 dash. Okay. Now, the intermediate pressure, so that is Pi or P2 is equal to 733 kilopascal, 733 into 10 power 3 Newton per meter square. Similarly, here the delivery pressure is 6000 into 10 power 3 Newton per meter square. Okay. Now, the low pressure cylinder. So, there are two pressures between this is operating. There is one compressor which is low pressure, the other compressor which is high pressure. Now, I could have completed this diagram. I am just waiting. If there is clearance volume, our diagram will change. All right. If there is no clearance volume, I am going to join this to this vertical line. All right. Now, the low pressure cylinder, let us call that as D1, is equal to 10 centimeter. So, that is 10 into 10 power minus 2 meter. Okay. So, that is 10 by 100, that is 0.1 meter. Okay. And the stroke for both cylinders. So, L1 and L2 both cylinders, we have 11.25 centimeter, that is 0.1125 meter. Okay. Assuming a compression, so PV power 1.35. So, N is given to us, PV power 1.35 is equal to constant. So, the value of small n polytropic index is 1.35, and that the volume of air at atmospheric conditions drawn in per stroke is equal to low pressure swept volume. The volume of air at atmospheric condition drawn is equal to low pressure cylinder swept volume. So, is saying that the volume of air at atmospheric conditions drawn is equal to low pressure cylinder swept volume. So, that is V1 is equal to Vs. Find the power when running at 250 rpm. Find also the diameter of high pressure cylinder. Okay. Since there is no mention about the clearance volume, let us close this now. So, since there is no clearance volume, I will bring it back till here, and this is our intermediate pressure. Okay. This is our suction pressure. Now, we can name it like this is our 4, this is our 5, and this is our 6. Okay. Now, let us go for finding out V1. I think we can find out V1. Now, V1 is equal to pi d square by 4 into length. So, this is our diameter 1, length 1, pi d square by 4 into length into n, we will get it in meter cube per minute. Now, pi into 0.1 square by 4 into L1 is 0.1125 into RPM is 250. Okay. Now, this will get it in meter cube per minute because this is in meter, this is in meter square meter. So, meter cube and RPM. So, we have substituted n in terms of minute, that is revolution per minute. So, we will get it in meter cube per minute. Now, shift pi 0.1 square into 0.1125 into 250 divided by 4. Yes. So, that will be 0.22 meter cube per minute, 0.22 meter cube per minute. So, that is our swept volume. So, 0.22 meter cube per minute. So, that is what was mentioned. The volume of air at atmospheric condition drawn is equal to lowest pressure cylinder swept volume. So, this is what is swept volume at the entry. All right. Now, the same swept volume, so this is our swept volume. Now, we can use this to find out mass handled at initial condition. So, P1 V1 is equal to MRT1, let us use this equation. Okay. Now, mass handled, now this is our M1 of course. Now, this is our mass handled at LP cylinder. So, that is lower pressure cylinder is equal to, so M1 is equal to P1 V1 divided by RT1. Okay. Now, P1 was given to us, P1 is 100 into 10 power 3, 100 into 10 power 3 and V1 is 0.22 meter cube per minute. Now, R for air is known to us 287 joule per kg Kelvin. So, this is the value we must know. Okay, we know that the R value is this. So, R value I will substitute it as 287 and temperature T1 is also given to us 288. So, 288. Now, let us check which unit we will get. Now, pressure is in Newton per meter square. Now, volume is substituted in meter cube per minute. Okay. And R was in joule. So, this is numerator actually. Now, R was in joule per kg Kelvin and temperature was Kelvin. So, Kelvin goes off. Now, meter square goes off. We will have Newton meter, that is joule, and joule goes off and this goes to the top. We will have mass in kg per minute. Okay. So, we will get the mass handled in the LP cylinder in kg per minute if we solve this equation, because we have substituted volume in meter cube per minute. Now, let us solve this equation. 100 into 10 power 3 into 0.22 divided by 287 into 288. So, that will be 0.266 kg per minute, 0.266 kg per minute. We can also write this in terms of kg per second. We can also write this in terms of kg per second, that is we will have to divide this by 60. So, 0.266 divided by 60 will give us the value kg per second. So, 0.00443 kg per second. So, that will be the mass of air handled at the lower lower pressure cylinder in kg per second. Now, let us go to the second part. I mean, we have found out the volume of air, we have found out. Find the power, okay, find the power. Let us go for find the power. Now, power is equal to, for multi-stage compressor, we have derived this equation n by n minus 1 P1 V1 multiplied by P2 by P1 whole power n minus 1 divided by n plus P3 by P2 whole power n minus 1 by n minus, this will be number of stages. We have 2 stages here. So, this will be our equation. Okay. Now, we can substitute this n by n minus 1. We have been given this value n is 1.35. So, 1.35 divided by, this is 1.35 minus 1 multiplied by, now P1, now our P1 is 100 into 10 power 3 into our V1 is, I will substitute this in per second, or we can also go for MRT1, that is also fine. So, V1 is 0.22 by 60, or you can substitute directly V1 is 0.22, I will substitute the same 0.22 divided by 60. Now, remember this will be in Newton per meter square, and this we have substituted in meter cube per second. So, this will be joule per second. Okay. So, that is what we wanted. Now, P2 by P1. So, do we have intermediate pressure? I think we do have intermediate pressure. Let us go for intermediate pressure, 733 into 10 power 3. So, that is 733 divided by 100. So, I am not multiplying it by 10 power 3, that will be anyhow cancelled out. So, this is 1.35 minus, so that is 0.35, I will substitute 1.35 minus 1 divided by 1.3 plus, now delivery pressure is also known to us, 6000 into 10 power 3. Now, 6000 into 10 power 3, I will not substitute again 10 power 3 here, because that will be cancelled out here. Now, divided by intermediate pressure is 733 P2, 733 whole power 0.35 divided by 1.35 minus 2. Okay. So, now let us solve this equation. So, I will solve the first part, that is 100 into 10 power 3. So, which is in the bracket, I am just solving that, 100 into 10 power 3 into 0.22 divided by 60. So, this will be our 366.6. 366.6 is our first part. So, I will simplify this as well, 1.35 divided by 0.35. Now, this is our first part. So, let us solve what is in the bracket. 733 divided by 100 power 0.35 divided by 1.35. So, that will be the first term within the bracket, that is 1.676, 1.676 plus, now the second part is 6000 divided by 733 to the power 0.35 divided by 1.35. So, that will be 1.72, and this minus 2 as it is. Now, if we solve this, I think we should get power in watts. So, let us solve it. .35 divided by 0.35 into 1.35 divided by 0.35 into 366.6 multiplied by multiplied by 1.676 plus 1.72 minus 2. So, that will be 1973.98, 1973.98 watts. So, if we divide this by 1000, we will get it in kilowatts, that is 1.97 kilowatt. So, that is the power required for the compressor. Now, let us go to the last part, that is find also the diameter of high pressure cylinder. Now, remember when we talk about high pressure cylinder, we are talking about the volume handled at 2 dash. So, we can write P2 V2 is equal to M R T2, but we are talking about the point T2 dash and V2 dash of course, and P2 is same, even you can write it P2 dash, but it is same as 733, that is the intermediate pressure. So, 733 into 10 power 3 and V2 dash is the unknown. Mass is fixed, we have calculated already 0.00443, 0.00443, that is the mass handled in both the cylinders. So, 287 and T2 dash is 30 degree Celsius has been given. So, 303 Kelvin. Okay. So, we will get V2 dash. Now, V2 dash can be calculated 733 into 10 power 3 alpha equals, I mean we were supposed to have this unknown alpha x, alpha equals 0.00443 into 287 into 303. So, we will shift solve for x is equal to 0. We will have 5.255 into 10 power minus 4, 5.255 into 10 power minus 4, and the unit will be, because we have substituted pressure in Newton per meter square, we are interested in volume, this we have substituted in kg per second, joule per kg Kelvin, and this temperature in Kelvin. So, we will have to get this in meter cube per second, because left side we have, I mean right side we have joule per second, left side also it has to be joule per second. So, this is meter cube per second. So, once we get this V2 dash, now V2 dash is what? Volume handled in the second cylinder. So, pi d square, pi d2 square by 4 into length into n, and remember the RHS should also be in second. So, I am dividing this minute by second. Now, this is 5.255 into 10 power minus 4, and pi d2 is the unknown, divided by 4 into L is same for both the cylinders, 0.1125 meter, 0.1125 meter, into N is 250 RPM. So, N is 250 by 60. So, this will give us the unknown, that is diameter, we will get it in meter. Okay. Now, let us solve this. 5.255 into 10 power minus 4 alpha equals, shift pi into alpha x square by 4, okay, into 0.1125 into 250 divided by 60. Now, shift solve for diameter. Now, the diameter is 0.0377, 0.0377 meter, or we can say multiply it by 100, 3.778 or 3.78. So, 3.78 centimeter. Okay. Thank you.